need to admit something about my job. For 9 years, I've built insurance models around one quiet assumption: rock is safe. Sand erodes, marshland floods, riverbanks slide. Those are the categories I price carefully, the ones that keep me up at night running scenarios. Cliffs, bedrock, granite coastline have always sat in my lowest risk tier. Solid ground, in my line of work, is the baseline everything else gets measured against. I've built a career on that baseline holding, and I've watched it hold, case after case, for nearly a decade, enough times that I stopped thinking of it as an assumption at all and started treating it as simply a fact about the world. Then my aunt called me from Normandy. Côte is my mother's older sister, and she's lived alone since my uncle passed, in a house that's been in her husband's family for 4 generations, perched on a stretch of chalk cliff along France's northern coast. Not the famous stretch, not the one on the postcards, just an ordinary, unphotographed piece of coastline that happens to have a house on it. She called on a Tuesday afternoon, her voice doing the thing where she tries to sound more annoyed than frightened. The local council had sent a letter. It used the word condemned. I do this for a living. I read geological hazard reports the way other people read weather forecasts. And I know, professionally, that condemned doesn't get used loosely by a French coastal authority. I asked her to read me the letter, and about halfway through I stopped being her nephew, giving casual reassurance, and started being the version of myself that shows up at work pulling numbers, asking about survey dates, doing the math out loud without meaning to. She kept asking me to just tell her whether the house was actually in danger, and I kept giving her the kind of careful, hedged answer I give clients, which is not what family members want to hear from each other at 10 at night. I flew out 2 days later. I told my firm I needed a week. I still didn't fully believe, sitting on that plane, that there was an actual countdown running under a house that had stood in one place for over a century. Paris meets you as a rehearsal for everything that follows: old stone, careful proportion, a city that has clearly spent centuries being told it's permanent. I didn't stay. I rented a car and drove north toward the coast, toward Normandy, watching the land flatten and green as the city fell away behind me, farmland giving way eventually to hedgerows, and then, as I got close, to the first glimpse of open channel water on the horizon. Colette's house sits above a stretch of coastline that geologists call the Côte d'Albâtre, the Alabaster Coast, a band of Upper Cretaceous chalk cliffs running well over 100 kilometers along the channel. The chalk itself is almost unbelievably old and unbelievably delicate at the same time, laid down some 90 million years ago, when a warm, shallow sea covered this part of Europe and a steady rain of microscopic marine organisms, their calcium-rich shells accumulating grain by grain on the seafloor, slowly compressed into the pure white limestone that now forms these cliffs. Dark bands of flint run through the chalk in horizontal striations, harder than the surrounding rock, resisting erosion just long enough to leave jagged black lines across every cliff face on this coast, like growth rings on something far too large to think of as a single organism. That same chalk layer runs beneath the channel itself and reappears on the English side as the white cliffs of Dover, proof that Britain and France were once physically joined, separated only when rising water breached the land bridge a little under 8,000 years ago. I'd known that fact in the abstract, the way you know any geology textbook trivia. Standing at the edge of Colette's garden, looking at open water where dry land had once connected 2 countries, it stopped being trivia. What I hadn't understood, professionally, until I actually pulled the research myself, is how differently this solid ground behaves once you start timing it properly. Chalk is a weak rock, mechanically soft enough that a fingernail can score it, and along this coast, it's being undercut continuously by wave action, freeze-thaw cycles, and heavy winter rainfall that seeps into the chalk and destabilizes it from within. Recent survey work puts average retreat along this coastline somewhere between 10 and 30 centimeters a year, and in the more exposed, more heavily rain-affected sections, closer to 20 centimeters a year, enough, over the lifespan of a house, to turn a comfortable clifftop garden into open air. It sounds small until you multiply it. It sounds small until it's the actual, measured distance between your aunt's kitchen window and nothing at all. Here's the part that genuinely upended how I'd been thinking about risk for 9 years. I'd assumed, without ever examining the assumption, that the most famous, most photographed chalk cliffs in France, the dramatic arches and needle formations at Étretat, the ones Monet painted more than 50 times, the ones on every postcard rack in Normandy would be the most actively eroding, simply because they're the most visually dramatic. The opposite turns out to be true. The chalk at Étretat happens to sit in a slightly different, somewhat more resistant layer than much of the surrounding coastline, and measured erosion there has historically run slower than at many of the plainer, unphotographed stretches. Just a few kilometers away, the exact kind of ordinary coastline Colette's house happens to occupy. The place everyone points a camera at is not the place actually disappearing fastest. The place actually disappearing fastest is the place nobody ever thought to name. I drove out to Étretat itself on my second day there, mostly to see the comparison with my own eyes. The formations are genuinely spectacular. Maniporte, an arch spanning some 30 meters where waves patiently exploited a vertical fracture until it opened clean through the headland. A freestanding chalk needle rising alongside it. The last surviving fragment of an arch that already collapsed. Cliffs climbing 70 to 90 meters straight up from a flint pebble beach. Tour groups photographed all of it with the specific, unhurried confidence of people who assume a landmark. This famous must also be permanent. 20 minutes down the coast, at the unremarkable stretch where Colette's garden ends, there were no tour groups, no protective monitoring stations, nothing but a for sale sign on the house, 2 properties down that I later learned had been listed at a steep discount specifically because of erosion risk. I was wrong about something specific? Standing in that comparison, I'd assumed that risk correlates with visibility, that famous, heavily monitored, heavily photographed places would be the well-understood ones, and ordinary places would simply be safer by default, since nothing dramatic seemed to be happening there. It's closer to the reverse. The famous places get studied, protected, occasionally even engineered against collapse, precisely because they're famous. The ordinary places get a letter in the mail, sometimes only after the crack has already opened. Julien Rocher was the one who'd sent that letter, and he was the person Colette had spent 2 days refusing to fully listen to before I arrived. He's the structural safety inspector for the local commune, a job that mostly involves routine building assessments and, a few times a year, exactly the kind of case that had brought me across an ocean. He'd surveyed the cliff edge behind Colette's property himself, twice, 6 weeks apart, and measured a visible widening in a crack running roughly parallel to the cliff face, the specific warning sign that precedes a chalk cliff section detaching all at once rather than eroding gradually. He wasn't guessing. He had numbers, a small waterproof notebook full of them, measurements going back years across a dozen different properties along that stretch of coast, most of which had never made the news and never would. What he didn't have, when I met him, was certainty about the timeline. Because chalk cliffs don't erode in a smooth, predictable line, they erode in fits, holding stable for months and then failing all at once, usually after heavy rain has saturated the rock from within. The storm arrived on my 4th night there, rolling in off the channel the way storms do on that coast, fast and with very little warning once the front actually turns. I was staying in Colette's guest room, which faced inland, and I remember being woken not by thunder but by Julien's headlights sweeping across the ceiling as he pulled up the drive well past midnight, having just come from the cliff edge himself. He'd gone out in the rain to recheck the crack before the worst of the storm hit, he told us, standing in Colette's kitchen dripping onto her floor, and it had opened further in 6 weeks than it had in the previous 6 months combined. Heavy rainfall is exactly the trigger that precedes a chalk cliff failure, water working into the crack, adding weight, lubricating the fracture plane, and this particular storm was forecast to dump more rain in 12 hours than the region usually saw in a month. He had a decision in front of him with no safe version. He could order an immediate evacuation on his own authority, based on a measurement he'd taken alone, in the dark, without the full engineering team that normally has to sign off on something this serious. Or he could wait for daylight and proper backup, the standard. correct procedure and risk that the crack and the section of cliff behind it wouldn't wait for standard procedure to catch up. Colette, for her part, had already told him 2 days earlier that she wasn't leaving her house over what she called a French bureaucrat's guess. Standing in her kitchen at midnight, watching Julien lay out exactly what he'd measured the width of the crack in centimeters, the rate of change compared to his last 2 surveys, the rainfall forecast printed out and slightly damp from the drive over, I understood for the first time that this wasn't actually a fight about a house. It was a fight about which version of uncertainty a person is willing to live inside, the uncertainty of trusting a measurement you can't fully verify yet, or the uncertainty of staying in a place you can't fully trust anymore. There was no protocol that told Julien which choice was correct, because there wasn't a correct choice available. Only 2 different ways of being wrong if the night went badly. He made the call to order the evacuation immediately, overriding the standard wait for full assessment procedure, on the strength of one measurement and a great deal of professional instinct built from years of watching this exact coastline fail in exactly this pattern, he told Colette. As gently and as firmly as I've ever heard anyone tell a French widow anything, that she had 20 minutes to gather what mattered to her. I will not pretend the next 20 minutes were calm. I will say that I have spent 9 years pricing exactly this kind of risk in the abstract, in spreadsheets, at a comfortable distance, and that watching my aunt decide in real time which 4 generations worth of objects could fit in the back of a car was the first time the abstraction actually had a face attached to it. The section of cliff directly behind her garden came down a little after 4 in the morning, while we were sitting in Julien's truck at the evacuation point a kilometer inland, unable to see it happen and unable to stop listening for it anyway. He got the call from the monitoring team a few minutes later. A significant section had failed, right where the crack had been widening, taking a meaningful strip of the garden with it. The house itself, set back further than the outbuildings, was still standing. It was also, by his estimate, now measurably closer to the new edge than it had been the day before. Nobody treated the night as a triumph, exactly. Colette's garden was gone. Her house, for the moment, was not. Julien told me over coffee the next morning, both of us running on almost no sleep, that calls like that one happen more often along this coast than most people outside the region ever hear about, and that the job has taught him to live with the specific, uncomfortable fact that being right in time and being right with full certainty are not always available in the same decision. He'd made calls like it before, he said, and been wrong in both directions at different points in his career, once ordering an evacuation for a house that stood untouched for another 2 years, once waiting for confirmation on a section that came down before the follow-up survey could even be scheduled. He didn't tell me either story as an excuse. He told them, I think, because he wanted me to understand that the version of him who'd shown up at Colette's door at midnight wasn't operating on certainty. He was operating on the accumulated weight of every previous night like it, which is a different thing entirely, and a much harder one to explain to someone whose house is the one in question. Once Colette was safely relocated to a cousin's house further inland temporarily, she insisted, though I suspect we both understood otherwise, I had a few days before my flight home, and I used them to see more of the country I'd flown across an ocean to briefly understand one small, unglamorous piece of. I drove southeast, eventually, toward the Alps, and stood for a while looking up at Mont Blanc, Western Europe's highest peak at 4,810 meters, its summit buried under snow and ice year-round. The mountain isn't a single dramatic spike so much as the visible result of an extraordinarily long argument between 2 continents, the African and European tectonic plates, colliding and compressing ancient seafloor sediment into the vertical structure now known as the Alps. A process that began roughly 65 million years ago and is technically, by geological standards, still ongoing. The Chamonix Valley below it is a glacial trough, carved by ice that advanced and retreated repeatedly over hundreds of thousands of years, each cycle reshaping the landscape a little further. Standing there, having just watched a French coastline lose several meters of itself in a single night, I found the mountain almost unbearably reassuring and almost immediately understood why that reassurance was slightly dishonest. Mont Blanc looks eternal on any human timescale. It is not eternal on a geological one. It is simply moving slowly enough that nobody standing near it has ever had to evacuate their house before breakfast. On the way south, I stopped briefly at the Gorges du Verdon, a canyon the Verdon River has cut some 700 meters deep through Jurassic limestone laid down around 250 million years ago, back when this entire region sat under a shallow sea. The water below runs an almost unnatural turquoise, colored by glacial flour, fine rock particles suspended in the current that scatter sunlight into blue and green while filtering out everything else. It's a canyon still actively being carved, the river patiently dissolving and widening the same limestone that once formed a seafloor, exploiting weaknesses in the rock to open fissures, hollow caves, and cut channels no one can see from the rim. Standing at the edge, I thought about how the same basic process, water finding weakness in stone and exploiting it year after year, indifferent to timescale, was simultaneously making a French river gorge more spectacular and making my aunt's garden smaller, the two of them running on the same physics at wildly different speeds and with wildly different reputations attached to the result. Central France offered a different, stranger version of the same lesson, the Chaîne des Puys, a line of roughly 80 dormant volcanic formations strung across 30-some kilometers of the Auvergne region, sits directly above the Le Mans Fault, a rift where the continental crust is slowly, almost imperceptibly pulling itself apart. The most recent eruption here happened only about 7,000 years ago, which in geological terms is closer to yesterday than to history. Standing on the slopes of Puy de Dôme, the tallest of the chain at just over 1,400 meters, looking down at cinder cones and crater lakes that all read, to the casual eye, as peaceful green hills, I thought about how completely dormant can be mistaken for finished, when it usually just means paused. I went briefly to Brittany after that, mostly because I needed a day that wasn't about erosion risk at all, and found the opposite problem waiting for me anyway. The pink granite coast runs for roughly 30 kilometers along Brittany's northern shore, granite that genuinely blushes salmon and copper rose at dawn and dusk, a phenomenon caused by high concentrations of feldspar that oxidize with weathering, an effect found in only a small handful of places anywhere on the planet. The granite itself crystallized some 300 million years ago, deep underground, during an entirely different mountain building episode than the one that made the Alps, and has spent the eons since being slowly uncovered and sculpted by exactly the same forces currently taking apart Colette's garden: wave, wind, weather, patient and indifferent to how photogenic the result happens to be. On the drive further south, I stopped near Bordeaux to see the Dune du Pilat, Europe's tallest sand dune, rising 110 meters above the Atlantic and stretching nearly 3 kilometers along the coast. Unlike almost everything else I'd seen that week, this landscape doesn't erode so much as migrate. The dune advances inland at roughly 5 meters a year, sand lifted from the beach and carried up the windward face by wind, only to avalanche down the far side, the whole enormous structure essentially climbing over itself in slow motion. During the medieval period, deforestation stripped away the pine forests that had been holding the sand in place, and the freed dune buried entire villages beneath it as it moved, leaving behind what locals still call ghost forests. Dead trees, stripped bare, emerging from the sand decades after being swallowed. Standing at the summit, watching maritime pine forests stretch inland in one direction and open Atlantic in the other. I thought about how this was maybe the most honest landscape I'd visited all week, because it doesn't pretend to be permanent even for a season. Its edges are different by the time you leave than they were when you arrived. I swung east afterward to the Camargue, where the Rhône meets the Mediterranean in a flat, marshy delta of shallow evaporation basins that run an almost unreal shade of pink, colored by a microscopic algae called Dunaliella salina that thrives in water saltier than 25% water, so concentrated it would kill most other organisms outright. Flamingos wade through these same basins by the thousands, feeding on the algae and on the brine shrimp that feed on it in turn, accumulating the pigment in their feathers until it becomes the color they're famous for. Salt has been harvested here since Roman times, seawater pumped through some 60 kilometers of increasingly concentrated pools before crystallizing into the white mounds, workers call camels, producing more than 500,000 tons of salt most years. It struck me as another version of the same lesson the flint bands in Colette's cliff had already taught me: an entire industry, an entire ecosystem, built directly on top of an extreme most living things can't survive, thriving specifically because it learned to work with the hazard rather than around it. On the way back north, I detoured to Mont Saint-Michel, the tidal island crowned by its Gothic abbey, rising out of a bay with some of the most extreme tidal ranges in Europe, over 14 meters during spring tides, enough to turn the entire bay from open water to walkable mud, flat and back again twice a day. The mount itself is a granite outcrop, a harder remnant left standing after the softer sedimentary rock around it eroded away over a much longer span of time. The same basic story as the needle at Étretat, told at a different scale and with a monastery built on top of it. I stood on the causeway watching the tide visibly moving across the flats faster than a person can walk, and thought about how this entire coastline runs on a version of the same lesson I'd flown out to learn from my aunt's garden. Everything here is being reshaped, constantly, at wildly different speeds. And the only real question is whether anyone is paying attention to the speed of the specific piece of ground they happen to be standing on. By the time I flew home, I understood something about my own job that I don't think I could have learned from a spreadsheet. Solid ground was never actually the baseline. It was just the category I'd been measuring too slowly to see move. Colette called me about a month after I'd landed back in Charleston. The commune had approved emergency funding to relocate what remained of her house's foundation further from the new cliff edge, not the whole structure, which turned out to be too costly and too uncertain to attempt, but enough of the original stonework and the family's most important belongings to rebuild, further back, on land that Julian's team had surveyed as stable for at least another few decades. She sounded tired in the way of someone who has finally stopped fighting a fact rather than a person. She'd also, she mentioned almost as an aside, started asking Julian for the actual survey data on her new plot before agreeing to anything, which struck me as the single most reassuring detail in the entire phone call. We talked for a while about the old house, what could be salvaged and what couldn't, and at one point she laughed, a little bitterly, and said that after 4 generations of her husband's family treating that cliff edge as fixed, it had taken an American nephew and a French bureaucrat with a notebook to finally convince her it had never actually stopped moving. I didn't correct her. I don't think either of us fully believed it either, before that week. I don't think the lesson I took from that week is really about cliffs, not only. It's about how easily solid gets treated, in my own head, and in an entire industry built partly on my assumptions, as a synonym for permanent, when the actual claim geology makes is much smaller and much stranger. Solid just means slow enough that most of us will never personally witness it move. I've spent 9 years pricing risk as though visibility and danger were the same axis, as though the places we monitor closely, photograph obsessively, build reputations around, are automatically the places most likely to fail. Étretat's cliffs taught me otherwise. The most dangerous version of stable is the version nobody thought to keep measuring. What stays with me most isn't the geology, honestly. It's the specific image of a man standing in the rain at midnight, recalculating a decision he'd already made once, because the ground itself had changed its mind faster than the paperwork could follow. I think about how much of what actually keeps people safe depends on someone willing to act on an incomplete measurement at an inconvenient hour against the preference of the person it most affects. I think, too, about how many other ordinary, unphotographed stretches of coastline, right now, are quietly doing the same thing Colette's garden did, simply because nobody with a notebook happened to be standing there often enough to notice. A short breath before I let you go. If this story changed how you think about what solid ground actually promises, I'd genuinely like to know which part of it stayed with you. Because somewhere on an unphotographed stretch of coastline right now, a crack is widening a few centimeters at a time, in a place nobody is currently watching closely enough to notice before it matters. How much of what we call permanent is really just erosion, moving too slowly for us to have called it by its real name yet? This narrative is told through the perspective of Caleb Whitfield, a fictional coastal geohazard actuary, and includes the fictional composite characters Colette Fournier and Julien Rocher. The geological facts, erosion rates, and historical details of France's landscapes described here, including the documented chalk cliff retreat rates along Normandy's Côte d'Albâtre and the comparatively slower erosion at Étretat, are real and presented as accurately as possible at the time of writing. The specific house, cliff section, and overnight evacuation described in this script are a fictionalized composite, not a documented real event.